so this is 2.3 part B, so you can already see I filled in all of that, so make sure you've watched that video. And then now we're going to talk about this part right here. So it says write an equation to represent the translated line. Let y, see that little 2, that just means the second y, so that's this column here. Represent the distance, and let x represent their time spent walking. Explain how this line is the same and different. So if we think about the equation, y equals 4/3, so that's this one. So notice in 3 seconds they went 4 yards. Well, if you think about this one, instead of 0 it was at 10, instead of 4 it was at 14, 8, 18, 12, 22. So the only thing that's different between these is this is 10, I'm not going to write that right there actually. These are all 10 more. Well, why are they 10 more? If we look back at this graph, aren't all of these points just 10 higher than this line right here? So it's just 10, they started 10 feet closer to school, so then that means they're still going at the same rate, or the same slope, which is what we just learned, but they're just 10 feet closer the whole way that they're walking. So what you're going to actually see is, remember, these are the values from when they just walked from home, and these are the values from when they walked from their aunt's house. So the equation is actually going to be y equals 4/3 x plus 10. And that's because it was the same rate. They were just 10 feet closer. Okay, so we're going to actually, before we do this step, I want to actually do 2B on the assignment. So if you look at the assignment, and I'm going to zoom in just so you can see it a little bit better. So we're going to actually do this problem right here. This is actually the problem that you're going to do on the assignment, but we're going to do this one together. So if we look at that, I want to find the rate from this graph. Now, so far, when we were finding the rate, we were using a table. In this case, we're going to find the rate, from graph. And sorry, I had to cover up what the problem was asking. But so we're going to find the rate from the graph. So if we look, and again I'm going to zoom in so you can actually see what I'm doing. And I'm going to switch markers so that it's a finer point. So if we look, this is right here between 100 and whatever that is. So let's count. So there are 1, 2, 3, 4, 5 to 50. So if you think about it, if I'm going from 0 to 50 and there are 5 lines, each line is going to be worth 10. So 10, 20, 30, 40, 50. And that's really, really hard to see. I'm going to have to write in pencil. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190. Okay, so now when we look at that, we're going to look at how much, or where this point is. So that's at 90. So you can, I'm going to go ahead and make the table just so that you can see it. So that first point, we know it started at 0, 0, and then the second point is at, remember, go along the x first. So that first point right there is at 6, 90. And then we have another one that's at 8, 120. Now, those are just the points that were marked. If you look along here, there was a point there. There was also a point there. So you could have used those points, but I'm just going to use the points that were marked for me already. But if there are no points, then you could make your own, just looking for, remember where they cross that grid, because then we wouldn't have to estimate and it would be exactly 230. So that's x, y. So we know this point right here goes up from 90 to 120. So 90 to 120. Remember, when we are doing these, we're finding that change from there to there and from there to there. We always set it up as change of y over change of x. What you will actually hear a lot of your teachers say for the rest of your math classes is rise over run, and we're going to write that in our notebook. So to find the slope, let me zoom out again. So to find slope, you will hear, or we've been saying, change of y over change of x. Or what you will hear a lot of teachers say, just because it's something that we've always said, is rise over run. What I like to say is y's. It's the y's, the change of the y's over run. The reason we say that is because this is how much it's going up. That's how much it's rising. So from 90 to 120, or if you use a calculator, you could say 120 minus 90 is 30. Or if we're looking at this graph, remember each line was worth 10. So let me zoom that in a little bit. So remember each line was worth 10, so it was 10, 20, 30. And then if we count this direction, that's the run, it's going from 6 to 8. So we go 6 to 7, 7 to 8, so that's actually 2. Or if you look on this side, it's also 2. So don't let the fact that you can, if I say find the slope from the graph, don't let that mess you up. You can also find the slope from the table if you just want to put them in your points. Okay, so this is very, very important for you to remember. So it's change of y over change of x, rise over run, y's over run. I like saying y's over run, rise over run. You have to memorize this. It's just something that you're going to have to do. So now let's look at this graph. If instead of starting at 0, what if we started at 50? So let's start at 50 instead. So we're going to start here. Oh, sorry, I didn't actually, sorry. I didn't finish the slope. So if it was 30 for every 2, you would divide 30 by 2. 30 divided by 2 is 15. So that would be our actual slope. You have to remember to reduce it if you can. And I know that that is the case because 30 divided by 2 is 15. Okay, so now we're going to start at 50. Actually, let's start at 100, just so that we don't run into those things. So we're going to still go the same amount up, or we're going to take each of these points and just add 100. Because remember, we're 100 feet up, or miles in this case, sorry. So then the next point would be at 190, which we're going to kind of run out of room, but that's okay. And it's still for 6. So 6 is up here, and we're going to go to 190. So that would be our line. Notice this one, our table would be 0, and it's 100 feet further up, and then it's at 6, and 100 feet further up. So 90 plus 100 is 190. So 190. Let's find our slope. So it goes up from there to there, and then it goes over that much. So from 100 to 190 goes up by 90, 10, 20, 30, 40, 50, 60, 70, 80, 90. And then it goes from 0 to 6. So that would be a change of 6. So let's do 90 divided by 6, and let's see what we get. So clear, 90 divided by 6 is 15. So notice they have the same rate. But if we're trying to find the equation, remember this one's equation, that first line, would be y equals 15x. That's the slope, that's the rate. This should hopefully all be reviewed because we've kind of been building up to this. But if it's not, that's okay. Just make sure you ask if you're confused. So remember, these had the same rate. 15 times 6 gives you 90. But remember, we started 100 miles further up or further along or whatever. So remember, your equation, just like we did just a second ago, would be 15x plus 100. Because they started further up. I know that's getting really, really messy, so that's why I'm going to write it in my notebook. So the slope is change of y over change of x, or rise over run, or y's over run. So our first equation we wrote was y equals 15x when starting at 0. Then it was y equals 15x plus 100 when starting at 100 miles. So they started 100 miles further ahead. So that's why everywhere along there, they're going to be further ahead. So, and you can draw a simple graph that looks like that. So this one would be 15x, y equals 15x. This one would be y equals 15x plus 100. Because, oh sorry, you couldn't even see that, because it starts further along. Okay, the last thing that we're going to do, I just flipped over to this side where we have our slope definition. Remember, this is the last thing we did in 2.3, is we talked about m as the variable for slope. So what we're going to do here, and you are going to see me switch colors quite a bit, but that's just the way I am. So an equation of a line we write it as y equals, and I'm going to use orange for m, x plus b. Hopefully you guys can see that b. Okay, so the m is our slope or rate. And you can say, you can point to the definition is on that page over here. So if I flip over, oh sorry, that was probably really loud, I hit the mic, is the slope. You probably want to add the part where we say rise over run, just so that it's all in one spot. So rise over run, remember that's the slope, like we just looked at on the graph. And then the b is starting value or starting position. We will also sometimes call it initial Like if you think about your initials in your name, it's the first letter. So initials is where you start. Initial value is where you start. So starting position is B, M is your slope. So if you look back at this, we know that the number with X is the slope. So our slope, or rate of change, so you notice we said or rate, is 15. And then this one, the starting value was 100. Remember, or keep this in mind, and this is the last thing I'm going to say and then I'm done. This is 15x. It started at 0. So really, in your last math class, or even in my class so far, it was showing plus 0 as a starting value. We just didn't actually say plus 0. So we even said it here. We said it was starting at 0. So technically there's a plus 0 there, but when you add 0, it doesn't change anything. So it's just 15x plus 100. This one would be 15x plus 0, but we don't write that. We just say 15x. So again, on the assignment, you're going to be doing this one right here. You will be giving the table, you'll be giving the rate, just like we did. But it's your choice on if you want to use rise over run, or if you want to find it from your table. Let me know if you need help.